Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have these problems: longest unequal adjacent groups, subsequence 2. So I will definitely suggest you guys to solve these particular versions, that is of Leetcode 2900, longest unequal adjacent groups of subsequence 1. That is just of before of that videos we have uploaded. The details video discussions, like details intuitions building to code iterations we have done there. So I will definitely suggest you to go to that video. So there we have built our own generalized template, and top of that we have done some modifications to get an AC for that. And these problems I have just used the exact same template, and the same template that I have submitted to the past submissions of that longest subsequence one. I have used the exact same code, exact same things, just a small minor modifications I did on that code to get an AC for this particular problem. So that's the reasons we have built a generalized templates when we have solved this particular video. So I will definitely suggest you, I will put the last video links to this video first comment sections, and I will pin it out. So please, definitely I will suggest you to go to that video first. Otherwise you will mostly get nothing on this when we are going to do the code iterations and the intuitions. Yeah, first we will understand the problem statement, and we will also on the simultaneously we will basically compare what actually has changed to these particular problems, to that past problems, that is of subsequence 1, what actually the change in the statements. So in this problem statement they have given a string array words and an array groups, both arrays having length n. Now the Hamming distance between the two strings of equal length is the number of positions at which the corresponding characters are different. So that we call the Hamming distance. So now you can see you need to select the longest subsequence for any subarray from 0 to n-1 such that the subsequence denoted as I0, I1, Ik having length k, the following conditions should hold. What's the conditions? For adjacent indices, the subsequence, their corresponding groups are unequal. I think these conditions are also valid here. The subsequence are alternating if for any two consecutive strings in the sequence, their corresponding elements at the same indexes in the groups are different. So exactly same things they have put. So they have also put that their corresponding groups are unequal. If we are selecting two consecutive elements of the final subsequence that you are going to provide, the indexes that we have choose, if we do it with groups of that indexes of any two adjacent elements of the subsequence that we built, both are different. Exactly same things. But here the problem is easy because our groups array only cannot be consecutive of zeros or ones, and at our groups array you can see the constant, our groups array is either 0 or 1. So our groups array can consist of either 0 or 1. But in this problem statement on the medium versions of this, which is longest unequal adjacent groups of subsequence 2, here you can see our groups can grow as big as n, So there is obviously a tweak on this particular problems. But if you remember right, on that particular video I already explicitly mentions, like we have solved this with groups value of any integer, not like only 0 and 1. So that's the reasons we have solved it already in different difficulty. Now we can use that same template to get an AC for a different questions or two. So that's the reasons I have repeatedly suggested on that video to get the gist of that template. That template you can use on multiple across mostly all the printing type of dynamic programmings, longest increasing, longest palindromic subsequence, this kind of longest subsequence, you can feed this template where they have asked to print the subsequence. You can use that template blindly. That is going to get an AC for sure. So now what extra difference we have for adjacent indices that we already gone through, words of I and words of j plus 1 are equal in length, and the Hamming distance between them is 1. The Hamming distance between them is 1. So these things is kind of new to us, because for the past problems only this groups should be unequal, then we are good. But here they are basically asking the subsequence that you have choose, groups to should be unequal, the consecutive groups of indexes to should be unequal, but words also have equal lengths, and their Hamming distance should be 1. And like this way, return a string array consisting of the words corresponding to the indices in order, like that's the subsequence they have asked for. In the selected subsequence, if there are multiple answers, return any of them. Note the strings in the words may be unequal in length. That is bound to be, right? The length of the strings, the words, the strings that they have given, like words of I can big as 1 to 10, but let's suppose words of 0 has length 3 and words of 1 has length 4. So that can happen. So now I can just quickly go to our OneNote to give you a gist what actually they are stating over this particular Hamming thing. So Hamming things is only new. To us. So here you can see. So what they told, na. So here you can see, if So first of all, so like groups should be different, that is same constant they have provided of the past, but what extra, so extra is on words also they have now put a constant. So when you are building a subsequence, all the subsequence are same length, all the words of that subsequence, that with that you have returned the answer, who should have same length and should have Hamming distance between the any two consecutive ones should be one. So what are the Hammings with one consecutive delta, with one consecutive delta of ABC? I can put this A, this first index can be replaced with X, that means anything's BC. So anything's with suffix as BC is in Hamming distance of length n. So that means these indexes we are equal, but only one index we are different. We are different only on index 0 here. So all the elements, all the consecutive elements of the subsequence that we are returning should have Hamming distance of 1. So that means they should be exactly identical, but exactly at one indexes they are different. So this can be anything. So this X can be anything except A. This can be anything except small a, like B to Z. This can be anything. Right? Another is what? A can be same. This particular portions we can put anything, and here that is also of like one distance from this, one Hamming distance from this. What else? AB we can put constant, and on the last index we can put anything. So on anything, so you can do like whatever this. If it is C, then X from A to Z, but except C. Here it is A to Z except B, right? So all are in Hamming distance of 1. So I think now the problem statement should be clear to us, but if not, I will definitely suggest you to go to this particular one-note expressions one more times so that you can get the gist of this particular lines what they are doing. But don't worry, I will do a test case iterations also, we will do. So there also you will get a gist for that for sure. So here you can see output. So that is the words they have given, and groups is this, and they have written BAB and CAB as an output. So now if we can read the explanations, a subsequence that can be selected is 02, 1, 2 they have selected, and BAB and CAB. So here you can see group 0 and group 2 are not equal. Yes, we have followed these conditions, 1 to unequal, and words of 0 of length, words of 2 dot lengths. The indexes that we have selected, like this and this, they have same length, and the Hamming distance between them is also 1. Because BAB, CAB, they have delta with only first index. Others are same. So Hamming distance conditions is also satisfied. There can be, I think, one more. Another subsequence that can be selected is 0, 1, like BAB and DAB, BAB and DAB, right? Group 0, group 1 not equal, 1 to unequal. Group 0 length, group 1 lengths unequal, and Hamming distance is also 1. BAB, DAB deferred by first index, so Hamming distance is also 1. So that is also a valid candidate. So another valid answer is BAB and DAB. So it can be shown that the length of the longest subsequence of the indices is only 2. So you can return either BAB or either BAB CAB. You can either return BAB CAB or you can return BAB DAB. On this example test case, like every groups are different and every words are in same length. And the Hamming distance is also 1. Just by naked eyes you can see it. So we can select 0, 1, 2, 3. It satisfies both conditions. Hence the answer is like words of 0, 1, 2, 3, like every all the words you can select from the words, and it has the largest length among all the subsequence of indices that satisfy the answer. Hence it is the only answer. Yes, so that's all about the problem statement. So you can see like the problems is exactly identical to what we have submitted on yesterday's on last days, or I have to say the yesterday's problems that Leetcode has given us. So just what the minor tweak they have given us, we know our submissions can work on any value of groups. We are not submitted anything like specifically work from 0 and 1. That was like looseness was provided on the easy versions. So groups of I is either 0 or 1, but we have submitted for any value. So it will exactly should work. But there should be a tweak. So I am very strongly I am suggesting you please go to that video before jumping to the medium versions. So yes. So here you can see on the yesterday's problems, we just have to check if groups of I and groups of J are not equals. Groups of I and groups of J are not equals. But today, tell me guys, what extra things we have to check? So if I am able to build groups of I and not equals to groups of J on yesterday's problems or the last problems, that is the easiest versions of this problem, we were good with this. But on today's there are more constraints. First constraint is words of I should be equals to, tell me, words of j, that also should be should hold, and the Hamming distance, Hamming distance should be 1. So how you can check the Hamming distance? So if you have A, B, C, D, and if you have B, B, C, A, how you can check the Hamming distance? You will iterate for every characters by characters, every character, if both are unequal. Okay, so we found one indexes where they have delta. So Hamming distance becomes 1. Same, fine. Nope, no same. This one is also no same. Sorry, what happened to this? So this one is also no same. The first one, here is it is also no same. What is happening? Microsoft projects. So that is also not same. So we have Hamming distance 2, but we are sure, right? Hamming distance should be 1. So this, if my I is here, and if I am choosing all the j's, I am assuming that you know how we are populating our j. So our j should be in range of this. So if Hamming distance is more than 1, it should be exactly 1. If it is 2 or if 0, then I and j we can't consider. But on yesterday, if groups are only unequal, then we are good. So here Hamming distance should be 1. First we will check if words length is same, and then we will check that Hamming distance should be same. So exactly these two handlings we have to put to get an AC for this particular submission. So now if we can go to the directly code iterations, because I am assuming you know the yesterday submissions, so or the easier version submission. So I have created it with a DP, a parent array, and I am populating for I in range n, dp.appends 1, and I will populate everyone's parent should be initially itself, and last largest indexes and max size to be 0 and 1. Then I have put what is the length of the indexes that I am considering to pair with any of its previous. I put its length, and I am for j, if the groups are unequal, then we have to check. What is the length of mine? What is the length of the j that we are checking? If length are same, okay, length are same, then we have to check Hamming distance. Here we have checked the Hamming distance. How we check the Hamming distance? Here you can see we have checked the Hamming distance very smartly. Here we can do a break also. I think it should work fine with this break also. Yes, it's working fine. So here you can see for first times we have created two variables only. First times, if it is a first time delta, and then we are allowing, because we know there should be delta with at least one indexes. That is at least one indexes. There should be a delta. So first time, if it is a first time, if it is creating a delta, so we are iterating for k in range mm, because we know everyone's length is same. And if we are checking words of I of k and words of j of k, if they are not equals, then we are checking. If it is a first time delta, then we are making first time delta is false, and we have put the mismatch indexes. Are we using this mismatch indexes? Right? Okay, we are not using. We can also get rid of this. I was like basically thinking of another kind of like storing it, but for the current it's not needed. So first time mismatch we are making it false, or if it is not a first time mismatch, so that means we already have a mismatch earlier with a particular indexes. Now we are getting mismatch with another indexes, so we are making valid false. So that is valid false means Hamming distance is more than 1. So don't need to check further. Break it. So now we have these valid things. This is only valid if Hamming distance is only 1. So now we are checking if it is valid, then only we can consider it. So if it is valid, then exactly same things I have done on the yesterday's. This logic is exactly same. You can see. So I have put size to be dp of j plus 1. If size is greater than dp of I have put dp of I equals to size, parent of I equals to j. Here you can see if size is greater than dp of I equals to size, parent of I equals to j. If size is more than max size is size, largest index size is this. So what we can do, we can quickly check with a diff compare. What is the diff? On that part we will only focus of both the submissions. So now if I can copy the whole of easier versions of it and put it on my left, and I am copying the medium versions of it and put it to my right, so you can see the difference. What extra things? So that is the function's name, that is Leetcode is only going to create the delta. We are not. So now you can see what the delta, what's the exactly delta is. So here we have storing it with an nn to the length of the words of I that we need to check very first, if length are same, then only we are considering, because we know here words length should be same, words length should be same. So we have checked. So that's the reason we have stored it with nn variables. Now you can see we have stored. We need the length of the j indexes also, j index words also. So if both are same, then only we are doing our job. You can see we have done exactly the same things to basically check the Hamming distance. And if it is valid, then you can see if it is valid, then exactly same job. There is no delta. Size to be dp of j plus 1, size equals to dp of j plus 1 if size is greater than dp of I. So this delta it's giving because there is a tab, there is a line tabbing has added because of this checks, because of this if valid check. So that's the reason it is giving the delta. But here you can see the exact length 1 2 3 4 1 2 3 4 5 6 7 1 2 3 4 5 6 7, these 7 lines exactly same. So if it is valid, no, so valid is only giving us if Hamming distance and length are same. If that is so, then we have done the exact same jobs of the yesterday. And below also no change, exactly same code is going to give us an AC. So see guys, so that's the reason I am repeatedly suggesting you guys to watch the videos in the way, in the sequence that I am uploading, so then you are not going to get an out of path. Okay, I am not understanding how this template is coming to an picture. So that's the reason I am giving you the templates, like creating the video in the sequence, so that you can get the Leetcode also giving the problems in the sequence. So if you have solved a particular easy problem with already a medium difficulty, next day or any successive days, we are going to get a medium versions or a hard versions of that, but we have already solved it on the harder versions of that. So same code is going to get an AC. So here you can see the exactly same things as well. So now I will quickly discuss the time complexity of this particular submission. So here we know we are doing a big O of n here, right? Another big O of n is needed to creating this, like creating our answer, and to reverse our answer is going to take another big O of n for sure. So yesterday's also, or the last easier versions also, big O of 3n we standard needed to this submission. So I can write it big O of 3n as standard. Time complexity is big O of 3n plus now the extra things. Here what extra things we have done? ij loops n square, yesterday's ones only big of n square, but take a note here, we are iterating one more for loop for k in range mm, that is of word length. And what is the maximum word length can we achieve? What is the maximum word length? It can be 10, it can go as big as 10. So there is big of 10 n square, now our n can be as big as 10 raised to the power 3. So the exact, so it is boiled down to how much it is? Tell me guys. Big of 3n, that is of 3000 plus big O of n square, that is of 10 raised to the power 6 into 10, that is of 10 raised to the power 7. So that is exactly it, 10 raised to the power 7 in plus big O of 3000, which is bound to be less than 10 raised to the power 8 for sure. There is no chance it is exceeding the 10 raised to the power 8 boundary, and it is giving you the AC for sure. So that's the reason I have created the template, and you can see guys, like with this template, how many same kind of problems with dynamic programming where they have asked for subsequence printing in dynamic programming. That is the template that you always have to be following. And what is the space complexity? On space perspective, I think the yesterday's one's only fine. So yesterday we have discussed, no? So big O of 2n, parent array and DP array. So today also DP parent array. Apart from that, do we use any more extra space? It's not needed. Yes, space perspective, it's exactly identical. So that is the most optimal solutions that I am able to think of, and I think there is nothing much to explain, but because we have already done the explanations, we have already digested our templates to the last video, so I have put the last video links to the first comment section, and I will pin it out. So I will definitely repeatedly suggest you guys, please go to that video where we build this template, no? So then this kind of problems is like a cakewalk for you for any interview. Like if they have asked for dynamic programming in sequence, in subsequence, and they are also asked to print it, then that is the template, that is the tabular DP template that you have to follow to get an AC. And if you guys are able to understand till this point, so please do subscribe to your channel, and please share the videos to your friend circle who are also preparing for top product this company and brushing up their DSL skills. And please turn on the notification so that when we are going to live to our next video, you will get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another video. Bye guys, bye.